Hello everyone, welcome to this video. In this video I want to take one problem which relates the roots of a quadratic equation with the trigonometric ratio, that is the tangent. So let's get started. I'll choose white color as my forecolor. So first of all, let me write down the problem. So we are given that tangent of A and tangent of B are two roots, are, let's call these alpha and beta instead of two roots, so it's easier to write. Alpha and beta are two roots of this equation, which is ab x squared minus c squared x plus ab is equal to 0. So this is the quadratic equation which has two roots, which are tan A and tan B, both being trigonometric ratios obviously, and we need to prove a couple of things. So let me write down those things that we need to prove. First, we need to prove that tangent of A is equal to A upon B. The second thing we need to prove is tangent of B is equal to B upon A, and the third part is the cosine of angle C is equal to 0, and the fourth part is tangent of A plus tangent of B is equal to c square upon AB. And then finally, the last part, probably the most interesting, is we need to show that sine square A plus sine square B plus sine square C is equal to 2. Oops. Yep, is equal to 2. Okay, so let's get started. Now if you think about the problem, it's obviously involving the concepts of quadratic equation, right? So we have to figure out our initial goal as we have done with the earlier problems. So since this problem involves trigonometric ratio of tangent, I don't think we have any formula that directly relates to tangent in our toolkit or list of formulae. So let's see how we can tackle this using basic properties of quadratic equation, like sum of roots and product of the roots. Just by inspection we can see that sum of the roots, let me make some space here. So hopefully you just wrote down this equation on a piece of paper, because it would be helpful to note this, because I am just removing this from my current view. Okay, so we know that the sum of the roots, which is alpha plus beta, is equal to the negative coefficient of the x term. So, and this holds only if the leading coefficient of x square is 1 or unity. So if we go back to our equation, in order to calculate the relations between sum of the roots and product of the roots, we need to divide both sides by the leading coefficient AB. So if we do that, this will become 1, this will be minus c square upon AB, and again this will become 1. So if you think about the sum of the roots, that is equal to the negative coefficient of x, which is c square upon AB, and if you think about the product of the roots, that is equal to 1. So let's write down these two results here. So alpha plus beta, or tan A plus tan B, because tan A and tan B are the two roots, are equal to c square upon AB. So just with this we proved the I believe the fourth part of the problem, And let's write down the second result from the basic properties of quadratic equation. This is equal to tangent of A tangent of B, and this is equal to 1. Now this is interesting because I want you to focus on this equation. What this is basically saying is that when you are multiplying two things or two entities, you are getting the product as 1. Now this can only happen in two ways. If you think about it, you multiply two numbers, you're getting 1. The first case can be when both tangent of A and tangent of B are equal to 1. So this is the first possibility, and there could be another possibility. The second possibility is that both are equal to -1. And I'm sorry about my horrible handwriting, but you could just ignore that. But if tangent of A is equal to tangent of B, which is either 1 or -1, only on those particular cases will this equation hold. So first let's consider the left case, which is if tangent of A and tangent of B are equal to 1 and each other. So in this case we know that A is equal to tan inverse of 1, which is 45, and so is B. And if you think about this, since we are dealing with a triangle, if we know that A and B are 45 degrees each, the third has to be 90 degrees, right? So this is the first possibility. In this, if we take the tan inverse of -1, this is equal to minus tan inverse of 1, which is minus 45 degrees. So since it doesn't make sense in context of triangles, we are just going to go with 45 degree case. Because minus 45 degree, you can think about this, if you just quickly draw the unit circle, this is 0 degrees, this is 180 degrees. So minus 45 is when you're starting from here, and instead of going in this direction, you are going in this direction. So if you go in this direction, this is minus 45 degree, which is the same thing as 45 degrees. So we don't need to worry about this case, so let's just ignore this, and let's draw our triangle with this scenario. So if this is the scenario, our triangle is going to look something like this. This is angle A equal to 45 degrees, this is angle B equal to 45 degrees, and this is angle C. It has to be 90 degrees in order to this to be a triangle, right? So sum of the angles has to be 180. Now we can prove all the results. So let's start with the first one. The first one was tangent of A is equal to A upon B. Well, that's true, because tangent of A is equal to the side opposite to angle A, which is A, divided by the adjacent side. Adjacent side is this one, B, this one, B, and this is the hypotenuse, C. So tangent of A is equal to opposite upon adjacent, which is A upon B. So this proves the first part. As for the second part, we need to figure out tangent of B. Now tangent of B is equal to the side opposite to angle B, which is B, divided by the adjacent side, which is A. So we proved the second part also. And if you think about it, since C is equal to 90 degree, cosine of C is equal to 0, obviously. And we already proved the fourth part, so we don't need to do that. And finally the fifth part, which is sine square A plus sine square B plus sine square C is equal to, is already proved, I guess, because since we know that A is equal to 45, which is also the same as B, sine square a plus sine square b is equal to 1 half plus 1 half, and then sine square c is equal to 1. So 1 half plus 1 half plus 1 is equal to 2. So that proves that as well. Now this was one of the approach, but I want to think about this in another way. So let's go back to our problem. So this was the equation. If you think about all the results that were asked in the question that we had to prove, we start from the starting. We see that tangent of a is equal to a upon b. This is what we needed to prove, and tangent of b is equal to b upon a. So I want you to notice couple of things. First of all, see the symmetry or pattern involved in the first two parts. Tangent of a is equal to a upon b, tangent of b is equal to b upon a. So obviously there is some pattern, there's some pattern or there's some symmetry involved in the problem. And also notice that this can only happen, these first two parts can only happen if we are dealing with a right angle triangle, but this is not mentioned in the problem. So we actually have to prove that this is a right angle triangle. So this is obviously one of the hints that we get from these two parts, and obviously also with the third part, since cosine of c is equal to 0, this implies that c has to be 90 degrees, again indicating that we are dealing with a right angle triangle. So this is actually an interesting problem. It has some symmetry involved in the problem, and obviously this proves this figure, this our triangle, proves that there is indeed symmetry in the problem since these two angles are the same. And yeah, so thanks for watching this video. Hopefully you found this interesting. I'll see you later. Bye.